In the last lecture, we have seen some special functions like beta gamma functions, and we have also seen about the differentiation under integral sign. So now, as we know about the single integral, we try to understand about the multiple integral. Okay, so what are the multiple integral and how we are able to solve the multiple integrals? So I hope you are able to see this journal. Is that okay?
Yes, sir.
Yes, sir.
Okay. So when whatever the integrals of it we have solved in one dimension. So we have considered the y as a function of x, and then we have solved the integral f of x dx with the limits or without the limits. So x was the only independent variable, and that's why these all integrals were one dimensional. Now we'll think of more than one independent variable. Okay. Or we'll think of the integral. Okay. So let I is equal to integral a to b integral so here we consider this limits for x and for y. We consider g1 of x, g2 of x, and we consider the function of x and y, and we integrate this with respect to dy dx. Okay. So when we consider the multiple integrals, the most important thing is order of the integration. Okay. So what is the most important thing? Order. Okay, so we need to understand what is the order of the integration. Okay, so order of the integration is not a number. Okay, so first thing we should be clear about the order of integration. It is not a number. Now, if it is not a number, then what it is? Again, so remember this. Order of the integration is the priority of variables which will integrated first and which will integrated later. Okay. So the order of the integration is the priority of variables. Okay. So see this integral. I have written dy dx. Okay, so what I have written? Dy dx. So for this integral, dy dx is the order of integration. Now the question is why only dy dx? Why not dx dy? Again, so the order of the integration is decided by the limits of integration. Okay, so what do we have here? So we have the order dy dx. Okay, this is order of this particular integration. Okay. Now here, when we consider the order dy dx. Okay, then there is a strip associated with this order. Okay, so what is the strip associated with this order? So the strip associated with this order is the vertical strip. So here we consider the vertical strip. So the width and the length. Okay, this is dx, and here this is dy. And here we can see that x is in the limits. Okay, so the variable x is in the limits, and that's why y will be integrated first. So we can see here y is expressed in terms of x. So when y is expressed in terms of x, then y will be integrated first. And then this constant limits are with respect to the variable x. So in this integral, the order of integration is dy dx. The strip under consideration is the vertical strip. And why this happens? Because in the limit we have x variable. So we have to integrate y variable first. By Fibonacci theorem, the same integral, okay, the same integral can be written using the change of order. So here y is running from c to d, and then here x will be running from the function of y. So h1 of y to h2 of y. And here the function inside the integral remains same, but we have changed the order now. Okay, so if x is expressed in terms of y, then x will be integrated first, and y will be with respect to the constant limits. So y will have the constant limits. And here in this integral, dx dy is the order of integration. So in this integral, dx dy is the order of the integration. And now the strip under consideration is the horizontal strip. Okay, so here we have to consider the horizontal strip. So what we have here, this is dy, and this is going to be dx. So here we have, this is dx. Okay, so you can see when we have the order dy dx, the strip under consideration is a vertical strip. When we have the order dx dy, then the strip under consideration is a horizontal strip. Okay, so this is very important for a multiple integral we first have to identify what is the order of the given integral. Once you identify the order of the given integral, then only we are able to evaluate the multiple integral. So here we are starting with the two-dimensional only x and y. Okay, so we are integrating with respect to x and y. Moreover, when we integrate with respect to one variable, the other variable is treated as a constant. So as we do in the partial differentiation, in partial differentiation, when we consider the derivative with respect to one variable, we treat the other variable as a constant. And so in multiple integral, when we consider the integration with respect to one variable, the other variable is treated as a constant. Okay, so this is very important thing in multiple integral. First, we need to understand what is the order of the integration. Then we have to evaluate as per the order. So, is there any doubt in this order of the integration?
Sir, can you please explain how to determine the order of integration?
Yes, exactly. Good. Okay. So when we have to determine the order of the integration, okay, first look at the limits of the integration. Okay, what we have to do first? We have to look at the limits of the integration. Once we see the limits of the integration, okay, then see that which variable occurs in the limit. Okay, so for example, you can see the limits are in terms of x. Okay, so if the limits are in terms of x, that means you have to integrate y first. Okay, so if the limits are in terms of x, that means you have to integrate y first. And if the limits are in terms of y, then you have to integrate x first. Okay, so if the limits are in terms of x, the order will be dy dx. If the limits are in terms of y, the order will be dx dy. Okay, or the other way we can say the variable which is in the limit should be integrated at the end. Okay, the variable which is in the limits should be integrated at the end. If you have constant limits for both the integral. Okay, so if you have constant limits for the both integrals, then you can integrate it arbitrarily. Okay, then you can integrate it arbitrarily. Okay, so is there any doubt now? All of you got this concept?
Yes, sir.
Okay. So if you got this concept, that's good. Okay. Okay. So let us try to solve some examples. So first, try to understand what is the order of the given integrals and then how to evaluate. Okay. So all the formulas, whatever we have seen for the integration remains same or remains applicable as they were. Okay. So let us try to evaluate the integral. I hope you are able to see this.
Yes, sir.
Yes, sir.
Okay. So we have the example here. Okay. Evaluate this integral 0 to 1, 0 to x square, e raised to y by x dy dx. Okay. So we go with the solution. Okay. What we have, let I is equal to integral 0 to 1, integral 0 to x square, e raised to y by x, and here dy dx. Okay, so first we need to understand what is the order. So always the first question is what is the order of this integration. Okay, so we have to see what are the limits. So you can see now limits. So what variable you can see in the limits?
X 0 to x square.
So we have, see, that's why we have to understand whether it is a function of x or function of y. So whether it is a function of x,
Yes, sir.
yes. Okay, so what will be the order?
dy
One.
dx.
Yes.
dy dx.
Yes. So here we have x is in the limit, so order is dy dx. And then we need to understand that whatever is given may not be the order. Okay, so whatever is given may not be the order, but here fortunately it is given as the order only. Okay, so order is dy dx. So that means we have to integrate with respect to y. Again, what we have to do is we have to integrate with respect to y first. Okay.
Sir,
Yes.
sir. So first dy is written or dx is written. That doesn't matter.
No, that doesn't matter. So we have to identify the order.
Okay, so we have to check only the limits.
Yes, yes. What is given, we don't have to trust that. We have to identify, and that is the first step. That in the first step, you are supposed to identify what is the order. Okay. So here, how we are able to write this? Integral 0 to 1, then integral 0 to x square. And here we have e raised to y by x. And this is dy. So we are integrating with respect to dy first and then with respect to dx. Okay. So what we know about the integration? So integration of e raised to ax dx is equal to e raised to ax upon a. Okay. So here, instead of x, what is the variable of integration? Y. We are integrating with respect to y. Okay. So we are having x as a constant. We have to integrate with respect to y. So let us try to integrate this. Okay. So when we integrate, this is the integration 0 to 1. Now here we have e raised to y by x upon 1 by x, because the value of a is here 1 by x. We are integrating with respect to y. Now, what are the limits? 0 to, so we have the limits 0 to x square. And then this is dx. Okay, so we have to be careful. This is 0 to 1. Okay, so we got here, it's going to be 0 to 1. And what this term is, this is x e raised to y by x. And this is 0 to x square dx. Is that okay?
Yes, sir.
Are you getting this? Yes. Okay. So now apply the limits. Okay. So what we have here? This is the integral 0 to 1. Okay. X is being constant e raised to y by x 0 to x dx. So don't be in hurry. Okay. This is going to be 0 to x square, right? Okay. So we have integral 0 to 1. X remains as it is. Okay. So now we have, if I apply x square, okay, so put y is equal to x square. So if we put y is equal to x square, are you getting e raised to x? Is that okay?
Yes,
Yes,
sir.
yes, sir.
Because x square by x, 1x will get cancelled and you will be having 1x here. Minus, we have to use the lower limit. So when y is equal to 0, what this term will be? E raised to 0 or 0?
E raised to zero.
Yes, e raised to 0. So we have to be careful. Okay. Now, let us apply this limits. So here, what we have, this is 0 to 1, x, and here we have e raised to x minus 1. Okay. So that's what we are able to get. Right. So is there any doubt in this example up to 8? So is there any doubt up to 8?
No, sir.
No. Okay, so let us simplify this integral. So we'll be having integral 0 to 1. I can write this as x e raised to x, and then this is minus x dx. Is that okay? Are you getting this?
Yes, sir.
Okay. So what we can do is, we can write this as 0 to 1, x e raised to x dx minus integration 0 to 1 x dx. Is that okay? Can we write
Yes.
it like this? Yes. Okay. So here we can use u into v rule. Okay. So what is u into v rule? It is u as it is integration of v minus derivative of u integration of v. Is that okay? This is exactly by parts rule, no?
Yes,
Yes,
sir.
sir.
Yes, sir.
So let us apply this rule. X remains as it is integration of e raised to x minus derivative of x and integration of e raised to x, and this limit is 0 to 1. Okay. Minus the integration of x is x square by 2 and the limit is 0 to 1. Now simplify, this is x minus 1 e raised to x, this is 0 to 1 minus half of x square 0 to 1. Are you getting this one?
Yes, sir.
Yes, sir.
Now apply limits. So what will be having? I is equal to. If I apply 1, what will be happen here? So it is 1 minus 1 e raised to 1, then minus 0 minus 1 e raised to 0. Is that okay? So here we are putting x is equal to 1 and then we are putting x is equal to 0. Now minus. So this is going to be half. So if I put 1, I'll be having 1 square minus 0 square. Is that okay?
Yes, sir.
Okay. So now let us simplify this. So 1 minus 1 is going to be 0. So this term is going to be 0. This minus and this minus will become plus, and we have e raised to 0 is 1. Now here, this is going to be minus half, and 1 square is going to be 1, minus 0 square is going to be 0. So we got 1 here. So we got 1 minus 1 half, and that is going to be. So what we got? We got I is equal to half. Or if I say I is equal to half, so I can say the integral 0 to 1, 0 to x square, e raised to y by x, ey dx. This is going to be half. Okay. So this is how we are able to solve or evaluate the multiple integral. Okay. So is there any doubt this example?
No, sir.
Okay. Is there any other doubt?
No, sir.
Okay. So if you have any doubt, you can ask. So I hope you don't have any doubt. Do you have any doubt? So if you don't have any doubt, then we'll go for the next example. Again, let us go for the next example. Let us think of another example. So are you able to read this question?
Yes, sir.
Yes, sir.
So here it is given that this is the integral over the area of triangle whose vertices are 0, 1, 1, 1, and 1, 2. Okay, so here direct limits are not given, but the area is bounded by this 3 vertices, and the boundary is the triangle with this 3 vertices. Okay, so let us try to understand. Okay, what we have laid, I is equal to integral over r x square plus y square dx dy. So we don't have the limits, and that's why we are not able to decide the order of the integration now. Okay, so where you can say where r is the triangle with vertices 0, 1, 1, 1, and 1, comma. Okay, so these are the vertices. Let us try to plot this area. So where this area is located. Okay, so we can have 1 here, we can have 2 here. So this is going to be 1 and this is going to be 2. So this is 1, this is 2, this is 1, this is 2, 0, x-axis and y-axis. Now think of this vertices. So 0, 1, where you have 0, 1, this will be 0, 1, then 1, 1. this is what you will be having 1, 1, and then 1, 2. So this is what you'll be having 1, 2. Are you getting this? What I says? This is 0, 1. This is 1, 1, and this is 1, 2. Is that okay? Are you getting this?
Yes, sir.
Yes, sir.
Yes. Okay. So if I draw the line passing through these 2 points, then it is the line x is equal to 1. Is that okay? Are you getting this
Yes.
line?
Yes.
This is going to be x is equal to 1. So if I draw the line passing through these 2 points, then it is going to be y equal to 1. Is that okay?
Yes.
Okay. And now if we draw the line joining to these 2 points, can you tell me what will be the equation of this line? Y is equal to, is that x plus 1? Are you able to get this?
Yes, sir.
Okay. So if you are able to get this directly, it's good. If you are not able to get this directly, and if you have the point x1, y1 and x2, y2, either 2 points, then the equation of line is given as y minus y1 upon y1 minus y2. This is same as x minus x1 upon x1 minus x2. Okay, so this is the equation of the line, and you choose any 2 points. So if I choose this 0, 1 and 1, 2. Okay, so suppose I choose 0 and 1, 2. So what you'll be having? This is x1, y1. This is x2, y2. So we got y minus y1 upon y1 minus y2. This is equal to x minus x1. X1 is going to be 0 upon x1 minus x2. So 0 minus 1. If you simplify, y minus 1 upon minus 1, and this is x upon minus 1. So y minus 1 is equal to x. So that means y is equal to x plus 1. This is what exactly we have used here. Are you getting this now? Okay, so this line y is equal to 1 and x is equal to 1 are easy to guess or easy to understand. So this is the 2-point formula that we can use, okay, to find the equation of the line. So using this formula, we are able to get the equation of the line passing through these 2 points, or we are able to find the equation of the line passing through any 2 points. Okay. Now, what is the area? Okay. So what is our area? The area or the region R is bounded by these 3. So this is the region. Okay. We got. So this is the region bounded by these boundaries, or we can say this is going to be the region R. Okay. Now it depends on you whether you want to consider the vertical strip or you want to consider the horizontal strip. As the order in this integral is not given, so we are free to choose the order. So here, without loss of generality, I'll consider the vertical strip. Okay. So now, when we think of x, so the limits of x are always from left to right, and the limits for y are always from bottom to top. Okay. So this is a general thing, or that you need to understand how to choose the limit of x and the limit of y. Okay. So here we have the region R with the boundaries as x is equal to 1, y is equal to 1, and y is equal to x plus 1. Okay, so these are going to be the boundaries. So this is the line here, this is the point 0, 1. This is the line x is equal to 1, and this is the line y is equal to x plus 1, and this is the line y is equal to 1. Okay, so consider the limits for vertical strip. Okay, so we consider the limit for vertical strip. Here we are considering this vertical strip. Okay, now if we consider the minimum value of x, so x is running from 0 to 1, because here at this point A, B, and we can say this is going to be C. So at this point A, the minimum value of x is 0. At this point B, the maximum value of x is going to be 1. So x is running from 0 to 1. Now we think of y. Okay, so what about y? See this strip and see what is the lowest limit or the bottom of this strip. So bottom of this strip is the line y is equal to 1. So that means y is running from 1. Now up to the top of this strip is y is equal to x plus 1. And that's why y will be running up to x plus 1. Okay. Now here, hence, we get I is equal to x limits are 0 to 1, y limits are 0 to x plus 1. And here we have x square plus y square. Now the order is dy.
Sir,
Yes.
sir, can I ask you a question?
Yeah.
Sir, sir, y is equals to 1 to x plus 1. Will it
Yes.
not be 1 to 2?
Yes, sir.
Yes.
Same.
Very good question. So when we consider y running from 0, 1 to 2. Okay. So y running from 1 to 2. Okay. So here we'll have the line y is equal to 1, and here we'll have the line y is equal to 2. Okay. So if you claim that x is running from 0 to 1, is there any doubt in x is running from 0 to 1?
No, sir.
No, sir.
Okay. So if we say that y is running from 0 to 1, that means we are claiming this area. So what this area, is it a triangle?
No, sir.
Is it given area? The
No,
given
sir.
area is a triangle, no?
Yes, sir.
Yes. So when you say y is running from 1 to 2, that means we are claiming this area. Is the area same that what is given to us?
No, sir.
Okay, so that means we cannot claim that y is directly 2. Okay, because when x is half, y is 1.5. Correct? Okay, so
Yes.
we have to consider the strip. Okay, so that's why we draw the vertical strip and the horizontal strip whenever required, whether it is vertical or whether it is horizontal. So we have to consider the strip, and then we have to consider if I move this strip over the area, again, what will be the top of this strip and what will be the bottom of this strip. Okay, so that will give you the y limits. Okay, and then up to left where we can move this strip, and up to what point to the right we can move this strip. So we can move x at the most 0, and we can move x right to at the most x is equal to 1. And that's why the x has the limit 0 and x has the limit 1. Okay, but if I consider in terms of y, then the bottom of this strip is going to be y is equal to 1, and the top of this strip is going to be y is equal to the line. It is the line y is equal to x plus 1. Okay, and not the line y is equal to 2. Is that okay now?
Yes, sir. Sir,
Okay.
can we consider a horizontal strip instead of a vertical
Yes,
one?
yes, surely we can consider horizontal strip. Okay, even we can solve the same problem using horizontal strip. Yeah, we can consider that also. Correct?
Thank you, sir. I got it.
Yes. Okay, so here when order is not given, definitely we are able to consider it. Got it? So now
Yes.
we got the limits here, and we got the order of the integration is. So x is in the limit, that means we have to integrate y first. Okay, so let us integrate with respect to y. So 0 to 1, integral 0 to x plus 1, it is x square plus y square dy, and then we have to integrate with respect to dx. So we can have 0 to 1. So when we are integrating with respect to y, x is treated as a constant. Okay,
So shouldn't it be from 1 to x plus 1?
yes, it should be from 1 to x plus 1, right? Okay, so here it will be x square will be treated as a constant. So what we get here, it will be x square as it is constant, and the integration of dy is going to be y plus you will be having y cube by 3, and here it is going to be 1 to x plus 1. Okay, and then this dx. So let us apply the limit. So it is 0 to 1. We have x square into x plus 1 plus we have x plus 1 cube by 3. This is the upper limit minus lower limit. So it will be x square into 1 minus 1 cube by 3. And this is dx. Are you getting this one? Are you getting this one? So 0 to 1. What we can have? X cube plus x square plus x plus 1 cube by 3. Okay. Then we can have going to be minus. So here we got, if I multiply this, then what you can have? X cube, this is x square, plus this is x plus 1 bracket cube by 3, minus x square and minus 1 by 3. And still we have to integrate it with respect to x. Okay. Now simplify this. So we can have 0 to 1 x cube plus x square plus, if we simplify, x cube plus 3x square plus 3x plus 1 by 3 minus x square and minus 1 by 3. And this all we have to integrate with respect to x. So it is 0 to 1. This is x cube plus x square plus x cube by 3 plus x square plus x plus 1 by 3. Are you getting these terms? Minus x square and minus 1 by 3 dx. Is that okay? So what you can cancel? You can cancel this x square and you can cancel this 1 by x. So you can cancel this 1 by 3, you can cancel this 1 by 3. You can have this x square and x square will get cancelled. What remains then? So we have 0 to 1 x cube plus x square plus x, and this 1 by 3 x cube plus x cube. So can we say this is 4 by 3? Is that okay? So here we have 1 and here we have 1 by 3. So it will be 4 by 3 x cube. This x square remains as it is, as this has got cancelled with this one, and then this one will be x. And now we have to integrate with respect to x. So is that okay? Are you getting this?
Yes, sir.
So this will be 4 by 3 x raised to 4 by 4 plus x cube by 3 plus x square by 2. And this is 0 to 1. Is that okay?
Yes, sir.
Yes. Okay. So now let us apply this. So this will be 1 by 3. If I apply x is equal to 1, so this 4 will get cancelled and you'll be having 1 by 3 plus this will be 1 by 3 plus this is going to be 1/2 minus you are using 0. So you can see 0 is everywhere. So it is going to be 0. Okay. So what we got here? We got 2 by 3 plus 1/2. So we can have here, this is going to be 6. Is that okay? So
Yes, sir,
the
5 by
LCM
6.
7 by 6.
Okay, so this will be 4 plus 3. So it is going to be 7 by 6. So here we got I is equal to 7 by 6. So this is the value of the integral. Okay. So in this example, what we have seen how to locate the area, and then we have seen how to write the limits of the integration. So here we can have the same area, but we can change the order of the integration. And once we change the order of the integration, so instead of dy dx, we can have the order dx dy also, and then we can evaluate. So is there any doubt in this example? Is there any doubt in this example?
No, no, sir.
No. Okay, that's very good. Now we have seen how to integrate with respect to x and then with respect to y, and then how to understand the order of the given integration. Okay, so let us try some more examples. Okay, so we go with one more example. So now if we see the Cartesian coordinates, then we can have the polar coordinates also. Okay, so what happens in polar coordinate? So let us try to solve one example. Okay, so we have evaluate integral 0 to pi by 2, 0 to 2 cos theta r square dr d theta. Okay. So this is the integral that we need to evaluate. So what we have, let I is equal to integral 0 to pi by 2, 0 to 2 cos theta r square dr d theta. Now here we have two variables r and theta, and check the limits of this integral. So what you find? which variable is in the limits? Which
Theta.
is the variable in the limit? Theta, because you can find here, this is 2 cos theta. Okay, so do you find r in the limits?
No, sir.
No.
No.
So which variable will be integrated first? Which variable will be integrated first? R. Yes.
R.
Okay, that's true. Okay, so here theta is in the limits, so that means r will be integrated first, and this is going to be order of integration. So as I said, in case of the Cartesian coordinates, we have to consider either the vertical strip or we have to consider the horizontal strip. In case of the polar coordinates, okay, so we have the initial line theta is equal to 0. We have the another lines as theta is equal to pi by 2, theta is equal to pi, and like that. And in this case, we have the radial strip. Okay. So in case of this polar coordinates, we have the radial strip. So this is 0, and here we can have r is going up to 2 cos of theta. Okay, so actually, what this 2 cos theta is? Again, so if you consider the relation between the Cartesian coordinates and the polar coordinates, so x is going to be r cos theta, y is going to be r sin theta, and what you have, r is equal to 2 cos theta. Okay, that's what we have. So if I multiply by r, then it will be r square 2r cos theta. Okay, and what we know about r square? R square is x square plus y square, and theta is going to be tan inverse of y by x. So here I have x square plus y square is equal to 2x. So what we get here, x square minus 2x plus y square is equal to 0. So can you tell me what this curve is? What this curve is going to be?
Ellipse.
Is it? So it's going to be a circle actually. So this is the circle with center, okay, at 1, 0, and a radius, okay, is going to be 1. Okay, so if I, yes,
Sir, how we got x square plus y square is equals to 2x?
yes. So what is the curve given to us? R is equal to 2 cos theta. Is that okay?
Yes, sir.
So we multiplied this equation by R.
Okay,
We
sir.
multiply this by equation by R. So I'll get R square is equal to 2R cos theta.
Yes, sir.
So R cos theta is X, and R square is X square plus Y square. So we got X square plus Y square 2X.
I
Right?
understand.
Yes. And then we simplified that this is going to be a circle with center at 1, 0, and the radius is going to be 1. So if I draw this circle, okay, so how this circle will look like? Okay, so here I have, this is 1 and this is 2. Okay, so this circle will look like this. So this will be the circle. Now theta is running from 0 to pi by 2. So as we can understand, these are the limits for r and these are the limits for theta. So what we have here, we have these are the r limits and these are the theta limits. Okay, so r is running from 0 to 2 cos theta. So this is the circle actually. R is equal to 2 cos theta, and theta is running from 0 to pi by 2. So this is the area of integration. So this dotted area is the area of integration. And now we have to draw the radial strip. So this is the radial strip we have. Okay, so in case of polar coordinates, we have to consider this. Okay. Now, once I know about the limits and order of the integration, then we are able to evaluate this integration. So let us try to evaluate this. Okay. So now evaluate the integral first with respect to r and then with respect to theta. So 0 to pi by 2, and then we have r is running from 0 to 2 cos theta r square dr. Then we have this is d theta. Okay, so that's what we have. Now, if we evaluate, so what we get here, 0 to pi by 2, and here we have r cube by 3, 0 to 2 cos theta, and here we have d theta. Now, if we apply the limit, so this 1 by 3 we can have a constant, so 0 to pi by 2, and this is r cube. So here it is 0 to 2 cos theta d theta. So this is going to be 1 by 3, 0 to pi by 2. Now here this is 2 cos theta bracket cube. Okay, so minus what you can have when r is going to be 0. So is that 0?
Yes, sir.
Yes. Okay, so what we will get here? So this is 1 by 3, then 0 to pi by 2. Is it 8 cos cube theta d theta? Is that okay? Are you getting this?
Yes, sir.
So it is 8 by 3, 0 to pi by 2, and we have cos cube theta d theta. So we have a formula, okay, to integrate this. What is the formula? The integration 0 to pi by 2 sin raised to p theta cos raised to q theta d theta. This is equal to 1/2 theta of p plus 1 by 2 q plus 1 by 2. Okay, so here this is going to be 8 by 3, 1 by 2, and beta of. We don't have any sign term here, so that means q, p is going to be 0. So here we have this is going to be half. And now we have cosine term, so the power of cosine is going to be 3. So it's going to be 3 plus 1 by 2. And hence we can have, this is 4 by 3, beta of half 2. Is that okay? Are you getting this?
Yes.
Okay. So now we can solve this as, so this is equal to, I is equal to 4 by 3. This is gamma half, gamma 2. And this is gamma of 2 plus half. So this is equal to 4 by 3. This is root pi. We can keep this as gamma half only. So this is gamma half. This is 1 factorial. And this is going to be gamma pi by 2. So we can write this as 4 by 3. This is gamma half. And here, this I can write as gamma 5 by 2 is 3 by 2, 1/2 and gamma half. So how we can write this? Gamma 5 by 2 is equal to gamma 3 by 2 plus 1. So it is 3 by 2 gamma 3 by 2. And this is 3 by 2 gamma 1/2 plus 1. Okay, so we can write this as 3 by 2, 1 by 2 and gamma half. Okay, so this is what we have here. Now, if we simplify, what you can have is, see, this is 4 by 3. Now, this gamma half and this gamma half will get cancelled. 1 upon, again, we have this 3 by 4. Is that okay? Are you getting this? So this will be 4 by 3 into 4 by 3, which is 16 by 9. Is that correct? Are you getting this?
Yes.
Okay, so we got the integral I is equal to. So we got here the integral I is equal to 16 by 9. Okay, that is, what is the integral that we were solving? The integral 0 to pi by 2, 0 to 2 cos theta, r square dr d theta. This is 16 by 9. So here we get the value of the integral in polar coordinates. Okay. So is there any doubt in this example? Is there any doubt in this example?
No, sir.
Okay. All of you got this example?
Yes, sir.
That's good. Now, let us try the another example. Okay. Are you able to see this? Are you able to see this example?
Yes, sir.
So here we have to evaluate this integral over the region x greater or equal to 1 and y greater or equal to x square. Okay, so let us think of where this region is. Okay, so we go with the solution. What we have here, let I is equal to integral over r dx dy x raised to 4 y square, where r is the region bounded by x greater or equal to 1 and y greater or equal to x square. Okay. So first of all, what we have to understand is we have to find what is x is equal to 1 and we have to find what is x is equal to y is equal to x square. Okay, so let us try to find these boundaries. Okay, so what you can have, this is x-axis, this is y-axis. So we can have 1. I want to find what is x is equal to 1. Okay, so we have here the line this is the line x is equal to 1. So what we have to do is x is greater than or equal to 1. So that means the area on this side. Okay, so what we have to understand is the area on this side because we want x greater than or equal to 1. So is that okay?
Yes.
Yes, sir.
So we got this area. Now we have to think of y greater than or equal to x square. So suppose y is equal to x square. What you will have, y will be always positive. So what is this curve? You will have
Upper parabola.
upper parabola. So can we draw the parabola like this? Is
Yes.
it a parabola? Yes. So this is the parabola y is equal to x square. And I want y should be always greater than x square. So what is the region? The region above this parabola. Is that okay? The region above this parabola. So exactly which region we can have when x is greater than 1, okay, and y is greater than x square. Okay, so this is the region that we have, or this is the region R exactly we want. Okay, so this is the region R. Now we can consider the vertical strip also, we can consider the horizontal strip also. So without loss of the reality, if I consider a vertical strip, okay, so suppose this is going to be a vertical strip. Okay, so here what we can have is y is equal to, what is the equation of this curve? Y is equal to x square. What is the equation of this line? X is equal to 1. Okay, and now see this region. Okay, so if we see this region, okay, what will be the limits? What will be the upper limit for x and what will be the upper limit for y?
Sir, is the region bounded?
Infinity.
For x, it will be
Both will be infinity.
yes. For x, it will be 1 onwards, and for y, it will be this curve onwards. Okay, so for x, x will be running from 1 to infinity, and for y, y will be running from x square to infinity. Okay, because as we don't have the upper bound for this region will go onwards. Okay, so x will be running from 0 to infinity, 1 to infinity, and y will be running from this curve to infinity. Okay, so we can write here for the region R, we have x is running from 1 to infinity, and y is running from x square to infinity. So y will be running from x square to infinity, and x will be running from 1 to infinity. Okay, so are you getting these limits?
Yes, sir.
Okay, so now we have considered the vertical strip. So what will be the order of this integration? Hence we get I is equal to integral 1 to infinity. The constant limits are always written first. Okay, so 1 to infinity, then it is going to be x square to infinity. Then we have 1 upon x raised to 4 plus y square. What will be the order? Is that okay?
Yes, sir. dy by dx.
dy dx. Now evaluate this integral. So once you know the order of the integration, we can evaluate. So 1 to infinity, x square to infinity. Then what we'll be having dy. We are evaluating with respect to y. So this x is treated as a constant, and then we'll be having dx. So we can have this is going to be 1 to infinity. Okay, so 1 to infinity, and here we have this is x square to infinity dy upon x square square plus y square, and this is dx. So is that okay?
Yes.
Okay, then we know what we know, the integration dx upon a square plus x square is equal to, okay, so it is 1 by a and tan inverse of x by a. Is that true?
Yes.
Yes. Okay, so here what is x? X is going to be y actually, and what is a? A is going to be x square. So we have the integration, okay, 1 to infinity, and here we have 1 by x square, and this is going to be tan inverse of y by x square, and then the limit is x square to infinity dx. Is that okay? Are you getting this?
Yes, sir.
Now apply the limit. So we'll be having 1 to infinity. This is going to be 1 by x square. So if I apply infinity, so it will be tan inverse of infinity minus 1 by x square, and this is tan inverse of x square by x square and dx. Are you getting this? Is that okay? So what we'll get here, the integral 1 to infinity. So here we have integral 1 to infinity. This is 1 by x square. What is tan inverse of infinity?
Pi by 2.
Pi by
This is going to be pi by 2 minus what we have here, 1 by x square, and this is tan inverse of 1. So what is tan inverse of
Pi
1?
by 4.
Pi by 4. So this is going to be dx. Okay. So here I is equal to, we can have, can we have this pi by 4 common, and we can write as 1 to infinity. Here we have, this is 1 by x square common. So can we have this going to be 2 minus 1 dx? Is that okay? Are you getting this?
yes.
So we have pi by 4, and this is 1 to infinity. So what we get here, we get 1 by x square dx. Is that okay? Are you getting this?
Yes.
Yes, sir.
That's true, right? Okay. Now we have to integrate this 1 by x square. Okay, so easily we can have, this is pi by 4, and here we have minus 1 by x, and the limit is 1 to infinity. So this is equal to, we have pi by 4. If we put infinity, this is going to be 0. Is that okay? If we put infinity, this is going to be 0. Minus minus plus, and if we put 1, it is going to be 1. So here, finally, we are able to get, this is going to be pi by 4. So here, we get the value of the integral is going to be pi by 10. So this way, we are able to evaluate the double integrals over the given region. So this way we are able to evaluate the double integral over the region. Okay, so the important thing is that how we are considering the strip. If it is given, we have to use it, identify the order of the integration, and then evaluate. Okay, so always we have to identify the order of the integration, and then we have to start evaluating. Okay. So is there any doubt in this example?
Sir, in this example, if we consider the horizontal strip, then what will be the limits?
Yes, very good. Okay. So here, if we consider the horizontal strip, okay, what we'll have, see, I'll draw the region once again, and then we'll consider the horizontal strip. Okay, so the region is this, y is equal to x square, this is x is equal to 1, and this point is going to be 1, 1. Okay, now if you draw the horizontal strip, so this is the horizontal strip. So here we have to write x is equal to square root of y. Is that okay?
Yes, sir.
Okay. So for this strip, we have to consider x is running from 1 to square root of y. And what will be y limit? Y is running from 1 to infinity. Got this one?
Yes, sir. I got it.
So now we have to use this limit, and the order will be dx dy. Okay, because we have considered the horizontal strip now. So the order will be dx dy. So in this case, we have to evaluate x first, and then we have to evaluate y. Okay, so you can verify by evaluating using this order also, right? Have you got this?
Yes, sir.
Okay, that's good. Okay, so here we saw how we are able to understand the order, how we are able to understand the limits of the even double integral. So we are in 2 dimension. How we have to treat in case of the polar coordinates. Okay, how we are able to locate the area and then consider the strip. Either we consider a horizontal strip or we consider a vertical strip. And then after considering vertical strip or horizontal strip, we evaluate the integral. Okay, so is there any doubt up to 8?
No, sir.
That's good.